Dear learners, welcome to the course Electromagnetic Fields. In this video, we are going to derive the expression for magnetic field intensity due to circular conductor. With the help of Savart law, here we are going to derive the expression for magnetic field intensity due to circular loop conductor. Here we consider a circular loop with a radius r which is placed on xy plane. Here, this is the circular conductor with the radius r. We are going to find the magnetic field intensity at point P. It is marked as point 2. With the help of Savart law, we are going to find. So, in a separate video, I have explained Savart law in detail. Savart law is used to find the differential magnetic field intensity. DH vector is equal to ideal vector cross AR vector by 4 pi r square. Here, differential current element is marked as 0.1. This is the location of differential current element, ideal vector. And AR vector is the unit vector along the direction of distance vector r vector. The r vector is the distance between the point 1 and point 2. So first we write differential current element ideal vector is equal to I or d phi a phi. Here the differential length is considered along the phi direction. Already we know that in the cylindrical coordinate system, the differential length along phi direction is r d phi a phi vector. So now ideal vector is I r d phi a phi vector. This is equation 1. Next we are going to write r vector. R vector is the distance between point 1 and 2. That means distance between the current element and the point where we are going to find the magnetic field intensity. Here the point is placed along the axis of circular loop. Now r vector is z vector minus r vector. From this we find the magnitude of r vector. Magnitude of r vector is nothing but, so this is the magnitude of r vector, root of r squared plus z squared. So from this we can write AR vector. AR vector is how we find that unit vector, vector divided by the modulus of the vector. Already we find the distance vector and then magnitude. We substitute here, we find unit vector. This is equation 3. So according to the Savart law, DH vector is equal to ideal vector cross AR vector by 4 pi r square. Here we substitute the cross product of ideal vector and AR vector. So ideal vector cross AR vector is nothing but this equation here. Z, here we include the term root of r squared plus z squared. This is the product, cross product of dl vector and AR vector. We substitute in this equation DH vector. Next we find the total magnetic field intensity. So here we integrate over the entire length. Here we consider the circular loop. Here we consider the circular loop. The phi values, it is phi is 0 to 0, phi is 0 to 2 pi. 0 to 2 pi. So now we are going to integrate over the entire length. This integrate with respect to phi. So therefore I by 4 pi integral of phi is equal to 0 to 2 pi r square d phi by r square plus z square power 3 by 2 az vector. Now we simplify this, we will get the expression h vector is equal to I r squared by 2 r square plus z square power 3 by 2 az vector ampere per meter. This is the expression for magnetic field intensity due to circular loop conductor. This is the magnetic field intensity along the axis of the circular loop. Suppose we consider the point P is shifted at the center of the circular loop means Z is equal to 0. Here, in the previous case, we consider it is point P is along the axis. Here we consider point P. Now this point P is shifted to the center of the circular loop. So now that means Z is equal to 0. We substitute Z is equal to 0 in the previous equation. Number 5. The H vector becomes IR squared by R squared power 3 by 2 AZ vector. It is simplified as I by 2R AZ vector ampere per meter, where AZ is the unit vector normal to XY plane in which the circular loop is lying. So in this way we find the magnetic field intensity due to circular conductor. I hope now you are very clear about the derivation of magnetic field intensity due to circular conductor by using Savart law. Thank you.